Hey, how's it going, geometry students? This is Mr. Shack coming to you with your Unit 4 test review. Yeah, okay, good. I'm recording. I was doing some weird things as I was trying to get this video started, so I really hope that it says it's recording now, so we're going to go ahead and hope that it is. Okay, so again, as always, I'm going to go through this very fast. It's about 4 p.m. right now, and I am trying to go home, so I'm going to do this. It's going to go quick, but remember, it's a video, so pause it, stop it, rewind it, and make sure you are going back and really understanding what I am saying, okay? Doesn't matter if you can copy everything down, okay? That does absolutely nothing for you. You need to be able to do these types of problems because these mimic your test questions. So that's what you're going to see on your test. You got to know how to tackle these types of problems. So let's hop into it. Okay, right away we have quadrilateral ABCD. It tells us side lengths. Then we have quadrilateral JKLM, tells us side lengths, and so on. Okay, but it's asking, are they congruent? Okay, if they're congruent, remember side AB should go with JK, BC should go with KL, CD with LM, and so on. So let's just take a look. Is AB congruent to JK? No, it's not. AB is 12, JK is 7. So at least the way they listed it, saying ABCD congruent to JKLM, no. No, they are not. And my explanation for that is exactly what I said. AB does not equal JK. All right, now if I wanted to go ahead and looking at this, 12, 2, 7, and 14, 12, 2, 7, and 14 is the side lengths of JKLM just in a different order. So if I wanted to say quadrilateral ABCD is congruent to something, I could. I just can't say it's JKLM. Okay, AB is 12, so I have to start with what's 12, and that's LM. And then BC is 2, so I have to go to MJ. All right, do you see what I'm saying here? And then CD is 7, so I go to where we have 7, and that is JK. So now I have a congruent statement. ABCD congruent to LMJK, but it is not congruent to quadrilateral JKLM. Okay, hopefully that made sense. Moving on down to number 2, we have two triangles, and I would always recommend drawing them. And it does not matter if you draw them to scale. Okay, I'm just drawing two triangles. I don't know if they're congruent or not yet. Well, I guess they are because it's saying which criteria can the student use to prove that the triangles are congruent. But then I'm just going to go ahead and label these things. So I'll call this one RST, triangle RST, and the other one is HIJ. So we will call this HIJ. Okay, then we are told ST is equal to IJ, so these two sides are congruent. I'll make my tick marks there right away, and they're both 14.6. So again, I'm just going ahead and labeling it. RT equals HJ, so RT, that's this one. I'll make two tick marks there, equal to HJ, both 10.1. Okay, so this is something you just got to be able to draw on your own. When you see triangle RST, triangle HIJ, draw two triangles. Does not matter if you draw them to scale at all. Make them look congruent, make them not look congruent. As long as you're labeling these things, then you should be able to figure out what it's getting at. Now we have measure of angle T equals J, measure of angle J. So these two angles they're telling us are congruent, and they're 29 degrees in here. Okay, and that's all we need to know. Look what we have. If they're both 29 degrees, well, and they're congruent angles in between two congruent sides, so we know this is side, angle, side. Side, angle, side. So that's D. Okay, so you just got to draw those pictures out, label it, and you should see which criteria it fits. Okay, even if your drawings don't look like mine. It'd be kind of weird if your drawings look exactly like mine, right? This is just how I chose to draw it. You don't have to draw it the exact same as me as long as you know how to label correctly. Either way, you're going to find that it's getting at a side, angle, side. Okay, looking at number 3, quadrilaterals TU, VW, and T prime, U prime, V prime, W prime are graphed in the coordinate plane. Okay, here is the original. This is the pre-image, and it gets over here to our image. We have to figure out what's happening. How do we get from this image here up into this image here? Okay, so I am thinking, all right, well, then what's something I have to do? First thing I notice, pause. If you haven't noticed it yourself, pause right now, figure this out yourself, and then check. Remember, you should be checking your answers with me, not just letting me give you them. Okay, hopefully you are unpaused now. And I'm reflecting across the y-axis. So reflecting across the y-axis is the first thing I'm going to do to get this guy to look more like this guy. Reflect across y-axis. And then I would go ahead and say, well, when I reflect across the y-axis, what that's doing is it's changing the sign of my x, right? If I'm at -3, well, then it's going to be at +3 after I reflect it. So it changes the sign of the x. And notice, it's not going to change the vertical location of any of these points at all. It's not going up or down at all. Y stays the same. Okay, once we get there, well, this is all reflected across. U actually stays the same because when you're reflecting across the y-axis, well, all of this is going to flop over, but U is on the axis, so it doesn't move. So let's just then see how we got to get U up to U prime now, because after it's reflected, you're just going to have to slide it up. Sliding it up 1, 2, 3, 4 is what gets you to U prime. So translate up 4. And notice how we didn't have to go left or right at all. It was strictly up 4. We didn't have to go left or right at all. So our x ended up actually staying the same. And when we go up 4, that's adding 4 to y. Okay, so when it's asking for the coordinate rule, now you're just combining your two rules. And the reason you look at this one transformation at a time is it's going to make this step way easier. Okay, now we have opposite of x and then x stays the same. So we strictly have opposite of x to start. And then we just have y. Well, and then this one says to add 4 to the y. So we have y plus 4. That is adding our two rules together. That's what you should get for your coordinate rule. You can check it too. Make sure this works with, say, v. Send it through this rule. See if it gets you to v prime. Pause the video, do that, and I'll tell you it does get you there. Okay? All right, let's turn the page. Let's keep moving here. We have triangle ABC, and BC equals 11 centimeters. We're told a few angle measures and so on, and then we're told stuff about triangle JKL. So again, when we're describing triangles, just draw a couple. They don't have to be drawn to scale. There's my first one. Mine are uglier than any of yours, I'm sure, because I am a terrible artist. Okay? I don't know if these are going to be congruent or not. They're sure not drawn to be congruent, but they probably are supposed to be based off of everything, but it doesn't matter. It's just getting all this stuff into picture form. So triangle ABC, I'll call this ABC, and then we also have triangle JKL, so I'll call this JKL. Okay? And as long as you're matching it up, like if I'm going A to B to C from left to right, I should go J to K to L from left to right. That's something I didn't mention in the last one. Okay, but that should happen that way. All right, now BC is 11 centimeters, so I'll label this 11. Angle A is 2y minus 2, so that's this angle right here, 2y minus 2. Angle B is 4y plus 8. Okay, I'm running out of room here, so we're just going to draw a little arrow here, 4y plus 8. Okay, that's angle B. And then angle C, we're also told, is 11y plus 4. Okay, then it goes on to tell us some stuff about JKL. KL is 4x minus 9. So we'll call that 4x minus 9. Angle L is 58 degrees right here. Angle B is congruent to angle K. Okay, so that means K is also, well, we can make a little congruence mark. Okay, K is also 4y plus 8. And then AC, don't know what it is, but it's going to be congruent to JL. We also don't know what that is, but I can make a little tick mark there. Okay. Now, it's asking what is the measure of angle A in degrees. Okay, so we have to think, well, all right, what do we know about A? It's not telling us that A is congruent to anything over here. So I really just have to go ahead and use what I know about a triangle, and then that's that angle A plus angle B plus angle C should all equal 180. Okay, so angle A, 2y minus 2, plus angle B, 4y plus 8, plus angle C, which is 11y plus 4. All of that now has to add up to equal 180. So I go ahead and I combine my like terms. Okay, I got to speed up. I didn't realize how slow I was going. I don't want to run out of time and get cut off. Okay, because I only have 30 minutes because I don't pay for this recording thing. So it cuts me off at 30 minutes. So I'm going to speed up. 2y plus 4y plus 11y. Well, 2y plus 4y is 6y plus 11y is 17y. And then negative 2 plus 8 is positive 6 plus 4 is 10. So combining like terms, I get 17y plus 10 equals 180. Then I have to subtract 10 from both sides. I get 17y alone now because those cancel, equals 180 minus 10 is 170. To get y completely alone, I have to do the opposite of multiply it by 17, which is to divide it by 17. That's what gets y alone. And what I do to one side, I got to do to the other. 170 divided by 17 is 10. So y is 10, but that doesn't mean angle A is 10. So now I have to go ahead and take what angle A is, which is 2y, but y is now 10, we found out, minus 2. So I just plug that into there. 2 times 10 is 20. 20 minus 2 is 18. So angle A is 18 degrees. And like I said, I'm picking up the pace. You need to start pausing, doing this on your own, and checking your answers with me, rewinding to listen to me explain it again, because I know I'm going too fast, but I have to. But it's a video, so slow it down, rewind, pause, back up. That's how you need to use this video. If you're not doing that, you're doing it wrong. Okay? What is the value of y? Oh, that's what we just found. Nice. Y equals 10. Okay? Just like that, we answered all the questions. So in this case, the picture wasn't a whole lot of help, but it could have been, and I think probably still was for anyone that calls themselves a visual learner. Okay, moving on down. We have triangles EFG and HIJ. They have the dimensions shown. Okay, it's saying for what value of x are the triangles congruent? Okay, and notice how they are listed. If they are going to be congruent, well then angle E has to be congruent to angle H. Angle F has to go with angle I. Well, here's angle I. That's what has our x, 5x plus 6. And I said that has to go with F, right? Because if they are saying these two are congruent, well then I is the middle one here, so F is the middle one here. So those go together. F is 96. So I can set it equal to 96. Okay, then I just solve for x. To get x alone, I start by subtracting 6 from both sides. I get 5x equals 90. To get x alone now, last thing I have to do is divide both sides by 5. When I divide both sides by 5, I get x equals, well, 90 divided by 5 is 18. So when x is 18, that's what makes angle I congruent to angle F, which that has to happen if these are going to be two congruent triangles because of angle, angle, side, right? Angle, angle, side. Okay. Oh, look at that. I just explained part B. We have angle, angle, and side. Angle, angle, and side. So that is the angle, angle, side congruence criteria. Let's keep cruising. Okay. Looking at number 6 now. A flooring contractor is laying triangle floor tiles with the dimensions shown. Okay, very cool. But we just care about what the value of x is. Now, if these are, it says a flooring contractor. Okay, now, if this is tiling, right, tiling has to be congruent. And, well, actually, we know these two triangles are congruent by side, 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 right? 7, 9, and 8. This has 7, 9, and 8. Okay, and the 46, sorry, that's a 48, I believe. 48 degrees is between side 8 and 9. And this one, 2x minus 14, this angle is between side 8 and 9 also. It doesn't matter that they're flipped. It's still between the two. So we can set 48 equal to our angle that's between 8 and 9 here, which is 2x minus 14. Okay, do we see how those angles correspond? We need to know that, okay, well, if this is tiling, then, well, the triangles have to be congruent. Plus they are, because they have the same side lengths, 7, 8, 9, 7, 8, 9. 48 is between 8 and 9 here. 2x minus 14 is between our sides of 8 and 9 here. So that's how I know those two go together. Set them equal to each other. Now I have to add 14 to both sides to start solving for x. All right, that is going to get 2x alone on this side. 48 plus 14 is 62. Lastly, to get x alone, I have to divide both sides by 2. That's what gets x alone. 62 divided by 2 is 31. So there's my answer there. Okay. Moving on here, we have two cables for number 7 of identical length. And they're used to support a bridge from the same height above the road as shown in the diagram. Okay, so, well, we have this side measure both being equal. Okay, and again, if this is, oh, yeah, and if this is a supportive structure, okay, used to support this bridge, well, then it's going to be identical on both sides. We know these are congruent triangles, okay? Now, it should have a right angle marker here, but again, we kind of assume that if this is a supportive structure, it should be straight up, making a 90-degree angle with the ground, okay? So if this is 22 and this is 90, well, then this angle here, which is also going to be x because they're congruent, these two angles have to be congruent. Okay, well then to find that, we have 22, that's that angle, plus 90, plus, well, whatever this is, which is going to be the same as x, so let's just call plus x, equals 180, right? Because the three angles of a triangle always add to 180. Now I can just solve for x. And if you did it a different way, saying, well, I can just subtract 90 and 22 from 180, yeah, that's essentially what we're doing. 22 plus 90, that is 22 plus 90 is 112. Sorry, my wife's texting me, making sure everything's okay. All right. Now, 112 plus x equals 180, just bringing everything down. Okay, I subtract 112 from both sides. That's what's going to get x alone, and I get x equals 68. Okay, so there's a few different ways of doing that. As long as you get to x equals 68, that's the important part. That's the answer. Okay, now going down here, place an x in the table to show whether each congruent statement is true or false. Can we say that AC, here's AC, is congruent to CE? Yes, we can. If you look, well, we know these two triangles are congruent because of side, angle, side, right? They share that in common. So that also means that this side, we'll call it 3 ticks, has to be congruent to this side. Okay, so yes, that's true. AC congruent to CE, because those are corresponding parts of congruent triangles. Okay, now BC congruent to DC. All right, here's BC, here's DC. Yeah, we're told that those are congruent. They each have 1 tick mark. Good. Now angle ACB, where's that? We got A to C to B, so that's talking about this angle. Is that congruent to DEC? That is this angle. That would not make a whole lot of sense if these two angles were congruent. So that is false. Now angle BAC, again here, B to A to C, so it's talking about the middle letter. We always look at the middle letter. So that's this angle. Is that congruent to DCE? Now again, that's this angle, congruent to that. No, that wouldn't make a whole lot of sense. Those don't correspond with each other. So again, that is false. Okay, so you got to know what angle it's talking about when you are given it in 3 letters like this. know that you are looking at, well, for ACB, A to C to B, then you're going to the middle of it. The middle letter is C, so that's this angle. And then D to E to C for angle DEC. Well, D to E to C, that is this angle. E is in the middle. So you got to know what angles they're talking about when you're giving it like that. Okay, we are on to the last page. Woohoo! Number 9. Let's get it done. We have quadrilaterals A, B, C, D, and JKLM. And they're congruent right trapezoids this time, where K is a right angle, where angle K is a right angle. Oh, that's period. Okay. If the measure of angle L equals 2x plus 7 and the measure of angle M equals 3x minus 18, what is the measure of angle C? All right, so we have to know what a right trapezoid looks like. So that's what I'm drawing. Right trapezoid is a trapezoid that has one right angle. Okay, well, actually, if a trapezoid has one right angle, then it has two, because it's going to be the one across from it also. So we'll call this ABCD. Oh, actually, you know what? We'll do KLM. JKLM. We're told K is a right angle, so I'll call this K. Wow, I can't write. Call this K. All right, and then measure of angle L. I guess we'll do L up here, and this is 2x plus 7. Okay, and then measure of angle M, that is this. Well, this, we're being told, is 3x minus 18. Okay, that's labeling everything there. And then we just have congruent right trapezoid ABCD. So if and then this would have to be J. So if I go JKLM, then I need to go from A to B to C to D in that corresponding order, making these two right angles. Oops, I'm off the screen a little bit. Sorry about that. Okay. And it's asking, what is the measure of angle C? Okay. So here's what we got to know now. It requires some prior knowledge. But if we have two 90-degree angles here, well, 90 plus 90, that's 180. And every quadrilateral adds up, their angles add up to 360. Okay. So 360 minus the 180, well, that means then just these two together, 2x plus 7, 3x minus 18, those have to add up to 180. So we have 2x plus 7 plus 3x minus 18. Those have to add to 180. Okay, again, because every quadrilateral adds to 360, all their angles add to 360. This is 90 and 90. 90 plus 90 is 180. So then I have 360 minus 180. Well, that equals 180. That means there's 180 degrees left over to go between these two. Okay, and we know if we find x, well, then we can find L, and C is going to be the same as L because those two correspond. They're in the same spot. Okay, so let's solve this for x. 2x and 3x combining like terms, that makes 5x. 7 and negative 18, well, that makes negative 11. Okay, so I get 5x minus 11 equals 180. I have to add 11 to both sides then to continue solving for x. I get 5x equals 191. Last step, to get x alone, I need to divide both sides by 5. And I get x equals 38.2 when I do that in a calculator. Okay, so x equals 38.2. So now if I'm going to find C, I need to find L because they are congruent. Again, I explained that earlier. If you missed how we know L and C are congruent, rewind a little bit. Okay, we have 2x plus 7. That's L, but we now know x is 38.2. So I replace my x with 38.2. Okay, and then I just go ahead and do 2 times 38.2. That is 2 times 38.2. Doing that in my calculator, that is 76.4. I add 7 to that, and that is 83.4. So I know that L is 83.4 degrees, And if L is 83.4 degrees, so is C. So I answered my question. Okay, last one here. Hopefully I don't get cut off. I don't know how much time I have. But a triangle has vertices with the following coordinates. It is graphed, and now it's going to be reflected over the x-axis. All right, and then after that, it's translated. So let's first reflect this over the x-axis. Let's call this A, B, C, so we know which points go with each other. If I'm reflecting C over the x-axis, well, it's 1 away, so it's going to be 1 away down here now. B over the x-axis, it is up here at positive 7, so I'm going to stay on this line and go to negative 7. There's B prime. Okay, and then A, again, it's on negative 9 line. X doesn't change, and it's up here at positive 8, so it is now going to be at negative 9 comma negative 8. There is A prime. Okay, I got to go fast to make sure I don't get cut off. Okay, that's our new triangle once reflected over the x-axis, and now it just needs to go right 5 units. So I just take each point, C prime, for example, 1, 2, 3, 4, 5. I just shift it over 5 to the right. That's going to be C double prime. I do it with B. Going over 1, 2, 3, 4, 5. Here is B double prime. And then A, I count 1, 2, 3, 4, 5 to the right. Here is A double prime. I connect my dots. This is my final image. Okay, so maybe I'm going to highlight that to let it pop out a little bit. Okay, there we go. That's our final image. Okay, this is our pre-image. This is the reflection, and then we translated it, so we go from this to this when both transformations are done. So let's see which is true about the image and pre-image. So we're talking about these two. The image is congruent to the pre-image because they have the same side lengths. Yeah, we didn't dilate. They have the same side lengths. So that for sure is true. Okay, we know it's not C or D because we didn't dilate at all, so we didn't. They're always going to be congruent if we didn't do any dilations. If we're just translating, reflecting, or rotating, it creates congruent figures. They do have the same side lengths, so A is correct. B is not correct because they say the image is congruent to the pre-image because they are both scalene triangles. Okay, that may be true, but that's not why they are congruent. Not all scalene triangles are congruent, so that's why A is our best answer. All right, glad I was able to fit that in. You guys make sure you rewatch if there is something you aren't understanding. Hope you were pausing, doing this on your own, and using my explanations as further guidance. I will talk to you later. Signing off.